Hello and welcome back. This video is going to cover arrays. Now, if you're new to programming, arrays are probably the first intermediary concept where you kind of have to start looking at a higher level of things. How are we going to be using different foundations and skill sets within our programs to make them a little bit more advanced? And so arrays, pretty much that first step. Now, arrays are basically variables that hold multiple variables. That's the quickest and easiest way that I can describe it, but as this video goes on, we'll kind of uncover what that really means. How I want to demonstrate arrays is, let's have this problem where we want to record the temperature of every hour in a day. So if you don't know arrays, you would start out by having maybe one variable called midnight, and it's going to be an int, and then we'll have 1 a.m. So we'll say 1 a.m. and then 2 a.m. so on and so forth until we make it all the way to the 24-hour cycle in a day. Now, as you can see, this is going to get quite tedious. We're going to have 24 named variables, and which is great because we can access them by a particular name, but we're going to have 24 lines just declaring variables, and then probably 24 other places where we're assigning some sort of value to those variables. So instead of having several variables, we're going to use an array. So let's delete this, and declaring an array is just like declaring any other kind of variable. So we have the var keyword, then we're going to name our array. So let's go with temps, and then we give the data type of what this is going to be. So first we have the bracket notation or the square brace notation to say this is going to be an array. And if we want all of our temperatures to be an int, then we just say int. Now there's one more caveat to this, and we have to specify some sort of size to go with this array. This array must know how many spots does it need to allocate once it's declared. And so if we're going to be recording the temperature at every hour of the day, then we're going to need 24 slots or variables within this array to go ahead and allocate for. So we can go ahead and print out this array and see what it looks like when it's printed out. So we'll do a format printf. And if you remember from one of my previous videos, we can just use %v to specify just printing out the value of some sort of variable. And so we'll put in temps here. Let's save and it'll auto import format for us. And let's run this. So if I do go run, we get an array printed out to us that has 24 zeros in it, because the 0 value for an int is 0, just like a 0 value for bool is false. And for character, it's like the \0 character. But if you go through and you count, you'll find 24 zeros here, just separated by a space, and they're enclosed within square braces. And now each location or each variable that we see here is called an element in the array, and each element in this array is at a particular location, and that location is called the index. So if you come from a similar language, or Go's predecessors or what it's built off, Java and C use zero indexed arrays, and so does Go. So what does zero indexing mean? It means that the very first location in this array is at index 0. The second position is at index 1, third position is at index 2, and then we go to all the way to size -1 index. So we have a 24 sized array here. So the very last element is at index 23. So let's go ahead and assign some of these just to drive this concept home. So if I want to assign or read a particular value within the array, we use the square brace notation. So I say the array's name, and if I want to specify a location, then I can go ahead and say 0 or 1, 2, 3, all the way up to 23. So I'm going to pick the first element in this array, and I'm going to assign it 1. And so let's go ahead and save this, run it again, and I will see that the very first element in this array has been changed to 1. Let's go ahead and do something similar. Let's go all the way to 23, and we'll change this to a 2. Run this again. We'll see that the very first element is still 1, and then the last element got changed to 2. Now you might think, what if I just accidentally go to 24? Because I have 24 slots, therefore I think that the 24th slot should actually be there. Well, let's find out what happens. If you hard code this, so I'm trying to access element 24 or index 24 of this array, we get a compiler error right off the bat. Go's compiler or the LSP is smart enough to see, hey, you can't actually go to index 24 because there's only 23 indices. But you can work around this little error is if we assign another variable to 24. So if I have x and I set it equal to 24, we'll say, hey, at position x, I want to assign it number 3. in X refers to 24. So let's go ahead and save this and see what happens. So we get an error, or what's more called a panic and go here. And what happens is that at main, we had some issue go on at line 12 right here, we can see at the end, and this is where we tried assigning the 24th index to 3, and that can't happen because that's out of bounds of the array. And so the program will go ahead and exit, say I can't, I'm trying to work with memory that's not been assigned, so go ahead and just exit. So we'll go ahead and remove this. And another thing that you should know is that we cannot assign other data types into an array of one particular data type. This array of temps can strictly only hold integers, cannot hold doubles, cannot hold characters. And just to be sure, if I try to assign temps at 1 equal to C, that will work because C, or characters and integers, can map to one another. But if I suddenly try to make this a string, we're going to have an error because it's a string trying to go into an integer slot. So cannot have other data types within the array. Just to demonstrate, I'll go ahead and have temps printed out again. So we'll do a printf with the %v. Don't forget the new line. Put in temps. But we basically just had this earlier, so I'm just going to skip the printing of this. The next initialization that we have is called array literal initialization. So number 2, array literal init. And this is where we're going to go ahead and just assign this to some sort of variable. So we'll have var temps2, and that's going to be equal to a slot of, let's just go with 3 right now because I don't want to put in 24 different values here, but we're going to hold 3 ints, and here we can specify the value. So I can do 1, 2, 3, and we're just getting this red line because we have not used this variable yet. But what this is doing is saying I'm going to stick an array of size 3 into temp2. Let's go ahead and have this be printed out and add in temps2. Let's save and let's see what this looks like. So do a go run at the bottom, and we'll see that our first array has all the zeros, and then our second one has the 1, 2, 3. So this is index 0, index 1, and then index 2. Now this 3 is actually unnecessary. We don't need to put it here. We can just take that out, save it, and then go ahead and do a go run here. And that works just fine because we're basically already saying what the size is by giving the literal values. Or we can do a ... That just does the same thing. Let's go ahead and run that, and we get 1, 2, 3 again. You can also specify that you're going to have 4 spots open up in this array, which means that when you go to print this, you'll actually get 1, 2, 3 because you specified the first 3 values, but then the last value was unset, so it just goes to the 0 value. Now that last trick I showed you is sort of just going into the third method of initializing an array, which is called sparse array initialization. So let's create a new one here. So sparse array init, and that's very similar to what we were doing up top, except we're specifying where the values can be in a larger array. So I have var temps3, it's going to be equal to, I will do 24 this time of ints, and here is where we're going to specify where all the values can be. So at the very first one, I can go ahead and say 99. That means that 99 is going to go into index 0, and if we ended it here, to be honest, all the other values would be 0. So let's go ahead and print what's going on here. Save this and run. We'll see that 99 was again set to the first value. Everything else is a 0 value. But what if we wanted to change up where maybe the last value gets set? And all the previous methods that we have up here, we would have to go all the way to index 23, specifically saying, okay, at index 4, I want it to be 0, 5 is going to be 0, 6 is going to be 0, so on and so forth. But with sparse array initialization, I can go ahead and just put a comma here and say at index 23, I want it to be 100. So I can do a go run here. We'll see the 99 is still there, and that 100 went all the way at the end. In between, I can do some other things. So I have a 99 right here. I can say I have a 65 right next to it. So index 0 will be 99, index 1 will be 65. I can just jump back around and do index 2, it will be 1. So then we'll have 99, 65, and then 1. And then I can continue, say 5, 8, 10. Now this looks a little confusing because it's not very consistent, but let's break this down. If there's no number or index assigned, it will go to the latest index before it that was assigned. So since there's no other index that's been assigned here, this goes to index 0. There's been no index specified here, so look at the last one that was assigned, it knows to go in index 1. Here we specifically said, hey, at index 2, I want it to be the value of 1. This looks at the index before it, so it says, okay, at index 3 will be 5, something similar, then we'll have 8, 10, and then we'll have a bunch of zeros all the way up to 23, which is set to 100. Let's go ahead and save this and just see what happens. Again, we have that that 60, 99, 65, 158, and then all those zeros, and then lastly the 100. Those are the three different ways you can go ahead and initialize an array. Now let's get into what 2D arrays are. Unlike matrix supported languages like Julia, Go only supports single dimension arrays, but we can simulate multi-dimensional arrays in Go. So that might sound a little confusing, but Julia actually has truly supported matrices while most other languages don't. So how would we create some sort of matrix simulation in Go? Well, it's actually similar just to what Java does and everything. So this is obviously a single dimensional array here, but if we go ahead and add or prepend a 7 to this, we'll say that I have an array of 7 arrays, which starts getting a little confusing here. So I have an array of 7 arrays, and each of those 7 arrays has 24 slots within it. So let's go ahead and save this. And actually what we'll do is change this and we'll call it to weekly temps, just to represent the problem that if I wanted to record the hourly temperature every day. So let's copy this and paste it there. So let's go ahead, clear the console or the terminal down here and do a go run. And this is kind of confusing output here, but we'll see that we have an array right here. So the beginning of the first, like this overall matrix here, then we have 24, then we have another set of 24 here, and we'll count that there's actually 7 different 24 slotted arrays. Now you may be wondering, okay, so how can I access a single element? Well, it's pretty simple. It's just like we were doing with the other arrays. Let's say that 0 index, so the 0th array represents like Sunday, and then the first index represents Monday or something. So I can go into weekly temps and I'll say Monday, or 1 in this case, and Monday's 12th index, we'll set it equal to 5. So we'll save this. So again, this is the outer array, or we're accessing the first index array, and then that array's 12th index. So now that we've saved it, let's go ahead and run this. So we'll see nothing got set in the first array here, but then in the second array, we got that 5 put basically right there in the middle. 2D arrays are great for things like this, where we know that we have 7 days in a week, and each day in that week has 24 hours. It's predetermined, easy to know, and it's not too difficult. We can continue to expand this logic into 3D arrays, 4D arrays, so on and so forth. But honestly, if you're going outside of 3-dimensional arrays, you're probably doing something wrong in your program. And 99% of the time, you'll really only need a single dimensional array. Lastly, we can go ahead and use the basic operators on arrays just like we can with strings. So let's clear that console and let's go back up here. Let's say that I have an array called A1 and it's equal to a single, just 1 slot array of int, and we'll set it equal to, it has the number 100 in it, and then we'll have var A2 that actually will just contain the same stuff. So we can go ahead and have a print statement here. We'll compare them. So %v, new line. So we can do the comparison operators. We can say A1 equals A2 just to see, hey, are these the same things? So if we go ahead and do a go run, we'll get trues printed out. If we go ahead and take out this 1 and put in 100 and 200, we'll actually get an error because these are 2 different types and we can't compare 2 different types. A single slot array different from a 2-slot array. So we can't even actually make this comparison. So if I take that out and we leave these as single slot arrays, we'll change this to a 101. And we'll see that when we go ahead and run this, we'll get a false printed out to the screen. One last thing that you might want to know is, what if I don't know the array's length? Which shouldn't be common because you have to know the array's length at compile time. But anyway, if we just wanted to print A1's length, all we have to do is use the built-in operator and just do len, wrap it in the parentheses, and we'll go ahead and get the size here. So it says it's size of 1. Let's go ahead and just change this to 100 for fun, and we'll see that when we run it, we get 100 printed out to the screen. All right, so that does it. Today, you learned a whole lot about arrays, about how they must be fixed size, hold only a single data type. They're basically a list of values, but it's very limited. There's a lot of constraints to the arrays, and it's basically what I just said, that they can only hold that single data type, that they're at a fixed length, and Also, in the next video, we'll cover slices, which addresses that fixed length issue. But we also learned that we can use the basic equality operators, we can figure out the length of the array, and also how to print out an array and what it looks like when it's printed out. And last but not least, we also learned that we could do 2D arrays, 3D arrays, and Go. But really, if you're going any farther past that, you might want to reevaluate how you're architecting your solution. With that out of the way, if you've made it this far in the video, I'd like to thank you, and please consider liking and subscribing, and I'll see you in the next one.